Hello and welcome class. So in last class we were studying about what is motion and we have learned the terms distance and displacement, and I have explained you that displacement is the shortest distance between initial point and the final point, and we have understand displacement through an example of a circular track. And I have also explained you that distance consists of a numerical value something like 35 and a unit like kilometers, and this numerical value in physics language called as magnitude. What it is called? It is called as magnitude, and this kilometer is unit. Now let's move forward. We have learned about the displacement, that the shortest distance between initial and final point, which is a straight line, is known as displacement. Now a question arises. Can the magnitude of displacement be equal to distance traveled by an object? The magnitude, it means the numerical value of displacement, can be equal to distance traveled by an object. Can you think about such an example? Suppose a person started from point A and reaches point B, and this person moved in a straight line. Okay, started at point A and ended in point B, okay, and moving along a straight line. Let this person is moved 10 meters. So according to you, or according to the definition of distance, what is the distance traveled by this person? The distance traveled by this person is 10 meters. Distance is 10 meter. What will be the displacement of this person? So what displacement say? Displacement say that the straight line between initial and final point is known as displacement. Initial point is A, final point is B. This is the straight line, and what is the distance of this straight line? The distance of this straight line is 10 meters. So displacement in this case is also 10 meter. So from this example, we have learned that if a person is moving in a straight line in one direction, not changing its direction, if the person is moving in a straight line, then the distance is equal to displacement. Is it clear, class? Okay, so now we will consider the example, that again carbon example, that a person goes from point O to point A, then return back to point C and passes through point B. Let's again move on to that example. So that person first traveled from O to A, and the distance between O to A is 60 kilometers. If I calculate the distance and displacement of point A, both will be 60 kilometer, because that person was moving in a straight line in a one direction, forward direction. Okay, so till 60 kilometers, the distance and displacement is same. But when that person change its direction and move backwards, okay, and reaches the point C, we know that till here it is 25 kilometers and this distance will be 35 kilometer. So total distance was 95 kilometers. And what will be the total displacement? O is the initial point, C is the final point, and the distance between initial point and final point along the straight line is 25 kilometers. So total distance is 95 kilometer, and what will be total displacement? Total displacement is 25 kilometer. Clear class? 25 kilometer that person has displaced, but that person has covered 95 kilometer distance. Now calculate how much this person has covered the distance and displacement if that person moved from O to A and then return back to point B, and we know that point B was 35 kilometer away from the origin and total distance was 60 kilometers. According to you, what will be total distance and total displacement in this case? What will be total distance? Total distance will be the sum of OA plus AB. Can anyone tell me what is the distance between OA? OA is 60 kilometers. What will be the value of distance between AB? Whole is from O to A is 60 kilometer. O to B is 35 kilometer. What will be B to A? B to A will be 25 kilometer, or AB is 25 kilometer. So total distance from point O to B will be via A. Total distance between O to B via A is 85 kilometer. And what will be the total displacement? So O is our initial point, B is our final point. So the total distance between O and B is 35 kilometers. So total displacement will be 35 kilometers. Is it clear, class? Okay, so let's move forward. So now we have learned the concept of distance and displacement. So the magnitude of displacement from O to B is 35 kilometer, but the path length is 85 kilometer. The object has changed its direction, so distance and displacement value does not matches. But we know that distance does not depend on the direction. But from this example, it is clear that displacement depends on the direction. Further, we will notice that the magnitude of displacement for a course of motion may be 0, but the corresponding distance cover is not 0. Let's again solve that example that you have gone from O to A and then return back to O position. Okay, what will be total distance and what will be total displacement? In this case, if you return back to your home, O position, what will be total distance? Total distance will be 60 plus 60, 120 kilometers. And what will be the total displacement? So again, whenever I ask you to calculate displacement, you have to first find out what is initial point and what is final point. So in this case, when the object started from O position, go to A, then return back again to O position, the initial point is O, the final point is also O. Can you draw the straight line between final and initial point? No, we cannot, because final and initial point are same point. So total displacement will be 0 kilometers. Because you haven't displaced anywhere. The point where you began, you ended up at that same point. So your total displacement is 0. For example, you go school from your home and then return back to your home. Your total displacement will be 0 because your initial and final point does not change, which is your home. So this type of condition, when object return back to its original position, total displacement is 0. But distance cover may not be 0. Such as in this case, total distance is 120 km, but total displacement is 0 kilometers. Okay, if we consider the object travel back to O, what I have explained is written here, that if you again return back to O, final position coincide with initial position, therefore the displacement is 0. Clear class? Your total displacement is 0. Okay, that calculation. Thus, two physical quantities, the distance and displacement, are used to describe overall motion of the object and to locate final position with reference to initial position at a given time. So to describe motion, these two both physical quantities, distance and displacement, are required. Okay, to calculate overall distance or to locate final and initial position, we need distance and displacement. And we also get the information that distance does not depend on direction, whereas the displacement depends on direction. Let's move further. Now, let's do another activity. Take a meter scale and a long rope. In your geometry works, you always see a centimeter scale, 15 centimeter scale. Okay. centimeter. Okay. Similarly to centimeter scale, there is 1 meter scale. Okay, so take a meter scale and a long rope. Walk from one corner to basketball court to the opposite corner along its side. Okay, it's a basketball court. You are standing here. From this position, initial position, you move in this direction and then you moved here. Okay. And rope is in your hand. Measure the distance covered by you and the magnitude of displacement. What difference would you notice between the two in this case? Okay. So this was your basketball court. This is you. You have a meter scale and a long rope and you move to the adjacent side. This is your initial position and this is your final position. Okay, if this distance, let's assume this distance is 10 meter and this distance is 10 meter. Okay. So what will be your total distance? Total distance will be 20 meters. Correct, class? 20 meter is your total distance, 10 plus 10. What will be your total displacement? This is your initial point and this is your final point. And what displacement says? Displacement says that the shortest distance between initial and final point, which is a straight line, is your displacement. So what we will do? We will draw a straight line between initial and final point. Now, how can you calculate the value of this distance? So this is 10 meter, this is 10 meter, and the angle between a square is 90 degree. So you have formed a right angle triangle where two sides are 10 meter and this is your hypotenuse. And what is the formula? Hypotenuse square is equals to perpendicular square plus base square. If perpendicular is 10, base is 10, you can calculate hypotenuse. Hypotenuse is equals to 2 into 10 square root. Hypotenuse is 10 root 2. So this distance, a straight line between initial point and final point, is 10 root 2. So total displacement will be 10 root 2 meter. We know the value of root 2, which is around 1.41. Multiply by 10. So total displacement is 14.1 meter. So you can see that the value of displacement is always smaller than the value of distance. So remember, displacement can be smaller than distance but can never be greater than distance. And in this case, your total displacement is 14.1 meter. Clear, class? Okay. Activity 7.4. Automobiles are fitted with a device that show the distance traveled. Okay. Automobiles like car. In car, there is a device which can show the distance, how much distance you have traveled, and that device is known as odometer. What that device called? That device called odometer. A car is driven from Bhubaneswar to New Delhi. Okay, a car is driven from Bhubaneswar to New Delhi. Bhubaneswar is the capital of Odisha. So, a car is driven from Odisha to national capital New Delhi. The difference between final reading and initial reading of the odometer is 1850 kilometers. Okay. So you begin with Bhubaneswar and you reached New Delhi. Okay. And the difference between final reading and initial reading means the distance between New Delhi and Bhubaneswar according to odometer was 1850 kilometers. This was the distance. Now find the magnitude of the displacement. This is the distance, means this much path you have traveled. But when you will use any Google map or road map of India, it will calculate the distance through a straight line. Means it will tell you the displacement. So you can check the value of this displacement using the road map of India. Okay, and you will find out that the value of distance between New Delhi and Bhubaneswar according to road map of India is less than 1850 kilometers. Why it is so? Because it is distance. In path between New Delhi to Bhubaneswar, there may be lots of curves. Okay, sometimes you have to move backward, then you have to move forward. Okay, sometimes there may be a slope, or sometimes there may be a valley which you have to cross, and that's how you will reach New Delhi. But road map of India will show you a simple and a straight line path between New Delhi to Bhubaneswar. So you will find out that according to road map of India, the distance between New Delhi and Bhubaneswar is less than the distance we are seeing here. It means that the road map of India work on the principle of displacement. Clear, class? So you can do this activity at your home. Now let's move forward. Now let's solve some problems related to all those topics which we have studied. Okay. And question number 1 is, an object has moved through a distance. Can it have zero displacement? An object has moved through a distance means the object has some distance. Can it have zero displacement? If yes, support your answer with an example. What will be the answer according to you? So answer is yes, as we have discussed that if original position or initial position coincide with the final position, then total displacement will be zero. Let's suppose a particle is moving in this way and reaches the same position where it begins, means initial position is coinciding with final position. Okay, in this case there is some distance, but displacement is zero. Clear, class? So any example in which initial position coincide with final position, then that object will have will covered or moved through a distance but has zero displacement. For example, you are walking or jogging in a circular track. Then your initial position and final position will be the same. So your total displacement is zero, but you have covered some distance. Earth rotating around the sun. This is sun and this is our planet Earth. Earth rotate around the sun and Earth need 365 days to complete one revolution. So after 365 days, the displacement of Earth is zero, but it has covered miles of distance, kilometers of distance to complete one revolution. So these are some examples of any object which has moved through a distance but has zero displacement. Clear, class? Let's see its answer. Answer is yes. An object can have zero displacement even when it has moved through a distance. And when this happened when final position of the object coincide with the initial position. For example, if a person move around park and stand on the place where he started, okay, moves around a park and ended up in the same position where he started, then his displacement will be zero. Okay, class? Now move on to next question. Next question is a very good question. And what this question asks? A farmer moves along the boundary of a square field of side 10 meter in 40 seconds. Okay, a farmer moves along the boundary. Okay, he completed one revolution. In 40 seconds. And each boundary is of 10 meters. What will be the magnitude of displacement of the farmer at the end of 2 minutes 20 seconds from his initial position? Okay, a farmer covers the boundary of a square field in 40 seconds. Complete one cycle in 40 seconds. After 2 minutes 20 seconds, how much displacement he does from his initial position? So let's convert this 2 minutes 20 seconds into seconds. So we know that 1 minute is equal to 60 seconds. Then 2 minutes is equals to 120 seconds. 2 minutes 20 seconds is equal to 120 plus 20, 140 seconds. Now let's find out number of revolution. Number of revolution will be how much time, okay, he take divided by how much time he has to take to cover one revolution, and after solving it you will get the final answer 3.5. So the farmer has completed 3 revolutions and 1/2 revolution. In 140 seconds. So farmer has covered 1, 2, 3 revolution and 1/2 revolution, means he begins from here, ended up here. This is the half revolution. So this was the initial point and this is the final point. How much will be the displacement? So how we are going to calculate this displacement? We are going to join this initial point with final point. This is 10 meter, this is 10 meter. We can calculate the value of this straight line IF. Clear, class? So let's see its detailed solution. This is the diagram. Okay, farmer has completed 3 revolution and 1/2 revolution. So if this was the farmer initial point, this will be the farmer final point after 3.5 revolution. Okay, so side of the square field is 10 meter. The parameter of square field is 40 meter. Farmer moves along the boundary in 40 seconds. So farmer is completing 1 revolution in 40 seconds. How much time we have given? We have given 2 minutes 20 seconds. We have first converted 2 minutes 20 seconds into completely second and it come out to be 140 seconds. So since farmer moves 40 meter in 40 seconds, 1 meter in 1 second in 1 meter, the farmer will move in 140 seconds, farmer will move 140 meter. In 140 seconds, farmer will move 140 meter. And number of rotation will be total distance divided by the parameter. Total distance farmer will cover in 140 seconds is 140 meter and the parameter of that square field is 40 meter. And we find out that the total number of revolution is 3.5 rounds. So if the farmer begins from A point, he reaches the C point in 140 seconds. This is 10 meter, this is 10 meter. Then we can calculate the value of AC by using Pythagoras theorem. And what Pythagoras theorem says? This will become hypotenuse, this is the base and this is the height. Pythagoras theorem says that height square is equal to perpendicular square plus base square. And after the calculation, 10 square is 100, 10 square is 100 and 100 plus 100 is 200 meter. And when we will calculate the square root, it will become 10 root 2. The value of root 2 is 1.414 multiplied by 10. The final answer is 14.4 meter. Thus, after the 2 minute 20 second, the displacement of farmer will be 14.14 meter. Okay. I hope this question is clear to you now. Next question is, which of the following is true for displacement? It can't be 0. Is it true for displacement? And B part is, its magnitude is greater than distance traveled by the object. Can displacement be 0? And we have learned that if initial and final point coincide, then the displacement is 0. So this condition is false, not true. Okay, so A option is not true. B part, its magnitude is greater than the distance traveled by the object. And we know that distance is always greater or equal, this is the symbol of greater and equal to displacement. So this statement is also false. Displacement can't be greater than distance. Okay, distance is always greater or equal to displacement, and we know the equal condition. Equal condition is when an object moves along a straight line in forward direction and does not change its direction, then distance and displacement are equal. But most of the case, displacement is greater than distance. Distance can't be greater than displacement. So both conditions are false. So its correct answer is none of the statement is true for displacement. Okay. First statement is false because displacement can be 0. Second statement is also false because displacement is less than or equal to distance traveled by the object. Clear, class? So this question is also clear to us. So in today's class, we have completed the topic distance and displacement. In next class, we will learn about uniform motion and non-uniform motion. I hope this class is clear to all of you. Thank you so much.